Hi everyone, this video is on exercise 9i, question 1 of pure 2. In this video, I'm going to do parts C and D. So in part C, we have the function f of x is equal to sine x, where x is between 0 and 2 pi. And we want to find the values of x for which the function is first convex and second concave. So just a quick reminder that a function is concave when the second derivative is less than or equal to 0, and it's convex when its second derivative is greater or equal to 0. So for question C part I, we want to find the values of x for which the function is convex, or the second derivative is greater than or equal to 0. But the very first step is just finding the derivative, the second derivative of f of x. So f dash x is cos x, and f double dash x is minus sine x. And now we want to find, because we want to know when the function is convex, we want to find the values of f double dash x that is greater or equal to 0. So let's substitute minus sine x here and see what happens. We have minus sine x greater or equal to 0, and multiplying both sides by negative changes the direction of the inequality, which you get sine x becomes less than or equal to 0. So this is now your inequality and you want to solve this. So note that if you want to find the values of sine x for which sine x is equal to, you want to find the values of x for which sine x is less than or equal to 0. So those values are simply when x is between pi and 2 pi, because just think about that. So sine pi is simply 0, and sine 2 pi is also 0, but the midpoint here is 3 pi over 2, and the sine of 3 pi over 2 is minus 1. So basically all the values that are in this range are between 0 and minus 1, which satisfies this equation. And also the bigger picture here is that the domain of x is just between 0 and 2 pi. So this is just another indicator that how we could easily just say this is between pi and 2 pi, because of course if the domain was r, then here the answer would be different. But here now the answer is much more restricted because of the rather short domain of x. Okay, now this is basically the answer, or we can just write this as if you like, as pi 2 pi. So this is the interval that shows the function is convex. So the second part is when the function is concave. So that happens when f double dash x is less than or equal to 0, which means minus sine x is less than or equal to 0. Again, just applying the same thing, multiplying both sides by negative, we get sine x is greater or equal to 0 this time. And as you might have guessed, this time the values of x for which sine x is greater or equal to 0 are when x is between 0 and pi, because sine 0 is again 0 and sine pi is also 0, but the midpoint is pi over 2 and the sine of pi over 2 is just 1. So the values in this interval will give you sine of these values is always going to be between 0 and 1, which means it's greater or equal to 0. And that's basically the values that give us the concave function. So it can be written in this form as well. We have concave function for these values. Okay, now part D, we have minus x squared plus 3x minus 7. Again, the first step, as usual, is finding the second derivative. So let's find the first derivative first and then the second derivative. So that's minus 2x plus 3. And now we can find the second derivative, which is just minus 2. So this is an interesting case. and maybe a simple case, or it can be confusing. So for part A, or the first part, again, we want to find the values of x for which the function is convex. And we said that the function is convex when f double dash x is greater or equal to 0. Now here there is a big problem, because -2, which is f double dash x, is not greater or equal to 0, right? This is not true. So this simply means that this function isn't convex for any value of x. So it's not convex for any x, or any value of x. So that's basically the part that I think is simple but can be confusing in a way. The second part is now checking if it's concave. So that's the case when f double dash x is less than or equal to 0. And in this case, this is also interesting, because what we are going to have is that the second derivative is obviously -2. And we know that -2 is less than or equal to 0. Now, what this implies is that this function is indeed concave for any value of x. So for all the values of x that you can find for this function, for f of x, the function is always concave, because the second derivative is always less than or equal to 0. So that's the interesting part of the second question. So you can say this function is always concave, i.e. x, the values of x that the function is concave is basically any value of x, or you can rewrite this as when for the values of x from -infinity to +infinity. Okay, so that's it for this video, and thanks for watching.